Hi, in this video we're going to solve simultaneous equations where one of the equations is the equation of a circle. We explored how to draw circles before, centered at the origin. So, for example, this second equation, it's not part of the question, but if we were to draw this second equation here, it would be a circle centered at the origin, and the radius of that circle would be the square root of whatever that number is. So this would be root 74, so that the radius of the circle is root 74. So that's root 74, that's minus root 74, that's minus root 74. So that would be what the equation looks like. And if I was to draw y equals 2x plus 3, the first equation, then it would look something like this. So basically, to solve these simultaneous equations is to find the values of x and y which satisfy both equations. And if we had the graphs, it basically corresponds to the points where the graphs intersect. So there's a value of x and a value of y here that satisfies both equations, and the same here. We've explored that principle before, that to solve simultaneous equations, you can sketch both graphs and then find where they intersect. That's quite an important principle. But we don't need the graph, we're just going to solve these algebraically. Now, remember in the previous video, what we saw is that we identify the linear equation. Remember, the linear equation is the one that x and y has no powers. So you can see x and y doesn't have a power. You might also have a constant term, which doesn't have any variables. So that's a linear one. Whereas this other equation, the x and y are squared. So if you have terms which are squared, then it's not going to be linear. So this is the linear equation here. And then remember that we substitute the linear equation into the nonlinear one. So this expression here of 2x plus 3, which y is, we basically substitute that into the other equation. So wherever we have y in the other equation, the non-linear one, we're going to replace it with 2x plus 3. So let's do that. So let's write out the second equation. We've got x squared plus y squared, but the y we said was 2x plus 3. We're going to substitute that in. And notice I've used a bracket because we want all of 2x plus 3 squared. And that is equal to 74, so let's write that. And now we've got a quadratic equation that we can solve in the usual way. So let's expand the bracket first. I'm going to just write the bracket out twice, but you might know the nice way that you can square a bracket quickly. And then we do each thing in the first bracket times by each thing in the second. So we do the 2x times the 2x, which is 4x squared. We do the 2x times by the 3, which is plus 6x. We do the 3 times 2x, which is plus 6x. And we do the 3 times the 3, which is plus 9. And that is equal to 74. And then let's just tidy up. We've got some like terms here. So you can see that we've got x squared plus 4 lots of x squared is 5 lots of x squared. We've got 6x plus 6 lots of x. We've got 12 lots of x. And then we've got plus 9 equals 74. Now remember, to solve a quadratic equation, we want to get 0 on one side. So let's subtract 74 from both sides to get 0 on the right-hand side. We're going to have 5x squared plus 12x, and then 9 minus 74, I should be able to do that in my head, but I'm being lazy, minus 65 equals 0. Now, this is a harder quadratic to solve because we've got a number in front of the x squared term that's not 1. The coefficient of x squared, as we call it, is not 1. And in previous videos, we've seen how you can factorize a quadratic like this, and please do watch those first. You could do something called splitting the middle term, but I think that's going to be quite hard here because when you do the 5 times the minus 65, you're going to get quite a large number. So what I'm going to do is sort of intelligent guessing of the brackets and think what might expand to give this, basically. Well, I've got to get the 5x squared in expansion. So this times this has got to give 5x squared. It's going to be 5x and x. We're slightly lucky because 5 is a prime number, so it can only be 5x and x. And also, two numbers at times to give 65. Well, it could be 65 and 1, but that would be quite lopsided. So I think it's going to be 5 and 13. Now, I don't think the 5 is going to go in this bracket because this has already got a factor 5. So I think the 5 is going to go in the other one here and 13 in here. And then we just got to get the signs right to make it work, because they multiply to give minus 65. So one of these two is negative, one's positive. And I think this is going to be the plus and this is the minus, because then if you think about the expansion, you can have minus 13x plus 25x, which is 12x. So this is the correct factorization. And now we've got a product of two things is equal to 0. If two numbers multiply to give 0, at least one of them is 0. So you're going to make each thing 0. So if the 5x minus 13 is equal to 0, well, we can add 13 to both sides and then divide by 5. So x is 13 over 5. Remember, the quick way of getting straight from here to here is just to negate whatever that number is. So the minus 13 becomes plus 13, and then divide by the number in front of the x. So 13 over 5, which is what you've got here. And then the same here, x is going to be, if you negate that plus 5, becomes minus 5. So minus 5 would be the other solution, because minus 5 plus 5 would give you 0 in that second bracket. Right, so we've got the values of x. There's two different values of x, which will satisfy this equation. But this is an equation in terms of x and y. But these equations in terms of both x and y. So we need to find the values of y which correspond with these values of x. So let's find this first y. If x was equal to 13 over 5, what would y be? Now, as I've pointed out in the previous videos on this, it's always easier to substitute into this linear equation here. So the y equals 2x plus 3, because it's just easier to substitute into something which doesn't have any squares and such. So y equals 2x plus 3. Now, I'm just going to use my calculator here. I'm going to put 13 divided by 5 on my calculator, and then I want to do 2 times x plus 3. So 2 times that answer plus 3, and that gives me 41 over 5. And then y could also be, well, if x is minus 5, I need to do, in this first equation, 2 times minus 5 plus 3, which is obviously minus 7. So we get minus 7 here. And just remember that you need to make sure that whatever the order of the values of x were, the y needs to be in the same order. So if your first value of x was 13 over 5, and the corresponding value of y was 41 over 5, that needs to be the first value of y, so that these link up and these link up like that. And that is the final answer.